So regarding Hadoop, you can install Hadoop on the Linux platform or Unix platform as such. Okay, you can also install it using hypervisor, right? If in case you are having Windows OS. Okay, so anybody having Linux OS? In your system? If you already have Linux OS in system, then you can download Hadoop, and then you can just install Hadoop using some instructions that I can pass it on to you. No, right? Okay, no issues. Everyone can see the screen. Okay, thank you. So the learning outcomes, we try to explain data warehouse and OLAP concepts, explain the data warehouse architecture and schemas, and introduce the concept of OLAP. Right. So this particular chapter will be more interactive because I'm sure all of you would have good exposure on these types of technologies as such. And this type of a dialogue from your side, because you're already in the industry, right, regarding how you're using data warehouse in your side. Okay, it'll also enable others, right, to have some good idea about how it is being used in the real time. So with this particular chapter, right, you'll be having a good understanding on the concept of OLTP, OLAP, right, data cubes, star schema, snowflake schema, fact consolidations, information processing, and analytical processing. Right. So as informed, these chapters, right, on with data warehousing, Hadoop Hive, right, analytic processing, and all those things will be mostly covered in your test, right? So these are essentially your learning objective towards your test, right? It's more just not test. Okay, so now coming data warehouse, right? Can I get some ideas regarding data warehouse? What is your idea about data warehouse? How are you using data warehouse in your office? I'm sure many of them will be using it. Just want to know like what type of data warehouse you're using and how it is being explored. Is it most of you are in the office? Can't open the mic, is it? Because I've not seen so silent. Our class always not so silent like this. Is my question clear? Yes, Lucian, BDW. What is BDW? Is it big data warehouse? Lucian. How about others? Is my question clear, or is it data warehouse is a new topic? I don't think so. I'm sure all of you, most of you would have been working on data warehouse by now. Those already in data field as well as in finance. Yes, data lake, right? It's a data store, right? But how can we say that it is related to the data warehouse? Okay, in the sense, the terms of processing is also fine with the data lake. Okay, in view of data warehouse. Okay, the reason why I'm trying to give you some detailed discussion, because nowadays many of them are brings to a common channel, right? Because we can say that some in some places, okay, the data lakes as well as takes the place of data warehouse. Okay, but usually data lake we can always use to say that it's something more related to the data marts, right? In terms of the data being collected and data being processed and all those things, right? Okay. So I think it does bring some sort of understanding here. Okay, but in many places, I'm sure that it is also in par with the data warehouse. Because most of the time, we are using only cloud, right? We are using cloud technologies, right? Even working in data warehouse, right? We are working only in the cloud. Hadoop is also in the cloud. Am I right? Pang Pao?
Yes, sir. Actually, we are using data lake. I'm not really having this opportunity to access to the data warehouse due to security issue in my company. So I actually find a lot of this kind of complexity of the data, and we call it as data ocean. I mean, we need to swim inside the ocean to get the data. So we are struggling at this moment. Yeah, thank you, sir.
Because these terms of data ocean and all those things, it depends only on that particular corporate. Am I right?
No, the data ocean is a word that we are trying to tease in because the data lake in our company is quite messy, the data. So we have to swim inside the data to get the data we want. So
okay, by the way, are you going with Databricks?
No, we are using data lake to get the data out. Yeah. Thank you, sir.
Okay, thank you. Okay, maybe you can give some details about data lake that you're using in your company.
Actually, we are not the person. I'm from finance, so I'm not involved in those technical things, how to set up the data lake, how to manage the infrastructure things. So mostly the data lake are built by the IT people or programmers. And we will just use the data lake to query whatever the data set we want from the data lake, and then to prepare our dashboard or Power BI, something like that. Yeah.
Those Power BI, all those things will be you're trying to get data, right? You'll be querying your data in the data lake.
Correct. Because we have a Power Query, we can directly query from the data lake. But I'm not able to direct query from the data warehouse because I haven't tried. I don't know where is the data warehouse in our company. Seems like they have something to control it.
Yes, that is what I'm trying to bring some clarity here, because I also wanted to know like how you are trying to do it in your industry's part, because this data warehouse as such, okay, we have data marts inside data warehouse, okay, and the thing that we are trying to use in terms of relatively corporates are using more of their own domain in cloud, okay. So how about others? Anybody using data warehouse as such? Okay, we have some answers from Lucian. Yeah, we do have some sort of an understanding, because when you talk about data lakes, data marts, right, we can understand with this type of technical details, right, along with data schemas, right? So, okay, maybe I can just give some clarity on this. Okay, so on data, we're talking about data. In data warehouse, relational data from transactional systems, operational databases, and line of business applications. All data, including structured, semi-structured, and unstructured. Okay, fine. So my question now is, okay, can all data like structured, semi-structured and unstructured, okay, cannot be in data warehouse. Can anybody highlight this one? Okay, one. Schema often designed prior to the data warehouse implementation, but also can be written at the time of analysis, right? Schema on write or schema on read. Fine. In data lake, what we do written at the time of analysis, which is schema on read, because we are trying to put all the data, can collect any data, and all the runtime data can be stored, right, in our data lake. That's one of the processing capabilities of data lake. We just try to collect all the data, right, all the semi-structured, structured data, and store it in our data lake. And later, when we wanted to do processing on the data, then we can have our schemas, right, written on Hive or such things to read, okay, or to do processing on that particular data. This is about the schema, which also means the data warehouse can have the capability of data and read, right? Fine. So take note of that. So price, performance, fastest query results using local storage, right? In data lake, queries result getting faster using low cost storage and decoupling of compute and storage, right? Decoupling of compute and storage, which means that we're talking about clustering, right? Clustering and taking into account details of data node and name node concepts, right? Okay. I'm sure those terms are already a little aware. Okay, maybe when we go with the lectures, right, we'll have more clarity on that. So we are trying to understand about how we are able to collect, right, or the streaming data being collected in the data lake. So about price and performance. Okay, so in data lake, I'm sure we can have the scale up and scale down, right? So in data quality, highly curated data that serves as the central version of the truth. And with data lake, any data that may or may not be curated, this raw data can be put, right? Okay, so this data quality, talking about data warehouse, okay, take note of it. Uses business analysts, data scientists, and data developers. In data lake, business analyst using curated data, data scientists, data developers, data engineers, and data architect. Okay, last one, characteristics analytics, batch reporting, BI, and visualization. In data lake, machine learning, exploratory analysis, data discovery, streaming, operation analysis, big data, and profiling. Okay. I'm sure all of you have a clarity on this now. Okay, my question now is, right, those who are already in this, right? So based on our discussion now with this very good characteristics discussion on data warehouse and data lake, okay, how much of a difference did you check with data warehouse and data lake? Right, when you see the schema itself, right, you can very well see that in data warehouse you can do both, right? Schema on write or schema on read based on the case by case, right? In data lake, of course, we are going to go with schema on read because we wanted to have all the data stored, right, on the real time. And when checking about data quality, users, analytics, right, you can very well see that it doesn't really seem to have a very vast major difference, right? Okay, so this really needs to be understood. This really need to be discussed, right? Discussed. And I'm also opening this question to everyone who are available in this platform now. So using data warehouse to collect data from different sources and store as tables. Okay. 10G, fine. Okay, take note of it. Is it only that? Question there, right? Next, from Nurul, data warehouse is greater than data mart. Yes, of course, because data marts are inside data warehouse, because data marts are based on the subject oriented content, or we call it as based on the departments. We can put our data in data marts, right? That's the reason why we say data marts are subject oriented. Okay, so which already means that data marts are, right, are contained in a data warehouse. Data warehouse as a whole is like a container. Fine. From Liu, sir, can we say data lake is more towards big data storage? Yes. Fine. That is the reason why we put it as schema on write. Schema on read, right? Okay, fine. Maybe shed more light on profiling in data lake. Okay. So data lake is more towards write once and read many. And data warehouse is write many, read many, hello update. Okay. So regarding data lake, okay, the discussion that has been provided, right, based on this characteristics, okay. So what I'm trying to get in understanding, right, from your side is to very well take note of the characteristic, right, both as a benefit and a limitation, right, as a benefit and the limitation of data warehouse and data lake. So when you say take about data lake, okay, you can very well see that it is having only one concept of schema on read, whereas in data warehouse we have both schema on write or schema on read. Once again, we put that as often designed prior to the data warehouse implementation, right? But also can be written at the time of analysis. Right? The reason why we are trying to put this is to get us an understanding about what we mean by data schema, right? Schema on write and schema on read. So usually in a traditional approach, when you talk about databases, right, we always go with schema on write because we wanted to input our data on tables, right? So which once again has us to have a very good understanding about how well we define the schemas so that our data can be very well inserted into those tables, which means that our traditional approaches where we have tables, we always have schema on write. Right. So the reason why we go with a very big store like data warehouse, right, is because to have the advantage of both schema on write and schema on read. Okay. Because now we are talking about data warehouse in cloud, right? Data warehouse in cloud. That is where I'm also asking you to have this sort of a justification from your side. So in data lake, we're just seeing that okay, it is only on schema on read, which means that it accepts all data as such, whether it's going to be structured, unstructured, right? Semi-structured, it accepts all data as it flows inside so that we are able to have the properties of the big data as such, because big data, we're talking about volume and velocity and veracity, right? Okay. So all those data can just be scooped inside our data lake, data warehouse as such. Okay, please take note of it. And our schema on read is going to be affected only when we wanted to make sense of the data that has been stored in our data store. Right? Only then we can use our tools, right? Maybe you can use Hive, right, to write a query, right? First define the structure of it, and then start reading it from the data store. Right? Are we clear in this, ulock? So please don't confuse our traditional database with our data warehouse and data store, right? So as such, data lake, right, has its own properties. But when you're talking of data lake in the cloud and data warehouse in the cloud, we will not see much difference unless until we have the functionalities defined. Right. So from Angpo, yes, schema on write and schema on read. This is what we're discussing now, right? So just to be very simple, right, to not to get too much confused, right? When we wanted to put our data into the table, right, it is called as schema on write because it is already structured. Because we are talking about table, it's a structured one. Whereas when you're talking about having all the data to be inside our data store, we just wanted to put all the data, whether it is structured, semi-structured, any structure. We just wanted to make sure that all the data is safe in our data store. And later we wanted to get some relevant information from that store. We need to have some sort of a procedure, right? So that procedure is nothing but our schema that we write to get information from the store. Right? So are we clear on that? Any doubt in this? Angpo, are we clear? You lock is clear. How about
Yes, sir.
others?
Clear.
How about others? Okay, everyone is fine. Okay, so still anybody else apart from Ang who are using data warehouse or data lakes, Databricks, or have been already using data pipelines as such? Right. So these techniques are mainly towards how we are able to collectively, right, source our data. Okay. So we'll go with the theory part, right, before we are able to understand more relative things. Okay. So I also want to get some interesting feedback from your side, okay, relatively how you're going to do that in your side. Okay, so hopefully we don't have doubts regarding this one. This chat from Angpo is a really good one. Are we clear in this? Yeah, fine. Structured data, unstructured data, is everybody clear on that? Anybody having doubt on what is structured data, what is unstructured data? OLTP and OLAP we'll discuss now, right? So in short, OLTP stands for online transaction processing. OLAP stands for online analytical processing, right? So these things are very much helpful when we are talking about schema on write, which is mostly on traditional data warehouse. Okay, I think we need to use this term nowadays because so that we don't get confused with anything else. And talking about big data and NoSQL systems, right? We can use schema on read. Heavy ETL tools role in stacking and moving data, right? Stacking the sense, right? How we do those process of storing and then all the other processing tools, processing things that we do with our data. So very low ETL tools involvement. Okay. So this once again needs some sort of an hypothesis, okay, based on the case. Okay. So modification of data model is costly. Schema is just a structured file, can be switched dynamically. Okay. And in schema on write works well in small data set. Of course, yes, that is very well to be noted, to be understood, right? That's the main reason why they have started exploring all these other venues, right? And schema on read ideal for large volume of data. Users know exactly what he or she is looking for. In schema on read, user is exploring the data without predefined questions. Okay, are we clear in this last points? In schema on write, user know exactly what he or she is looking for because we already have a structure, right? We know what is attributes. Okay. How about in the schema on read, user is exploring the data without predefined questions. Because when you start writing the schema, right, you start writing the schema on read, You already are studying the data, right? Only then you are writing the schema for reading, right? So once you start doing that, you already will have, right, some sort of values added, okay, towards your particular process, which means that you are going to go with what you want to do with your data, right? The reason why we are trying to put it in this way, like user is exploring the data without predefined questions, right? Because initially we are not very clear with what is the value that we are having with the data, right? Hope this is clear. Are we clear in this understanding? Is anyone having a doubt with this structured data, unstructured data, about what we're trying to discuss, the schemas and all as such? Anybody? Because I'm sure some of them are having sufficient knowledge with their companies and all those things, like, okay. Yes, Lucian. Okay, so since data warehouse can be schema on read, does it mean it also accept unstructured data too? Yes. We're talking about current versions of data warehouse. Depends upon what version we are using. What the version in the sense, like, who's the provider? Am I clear, Lucian? Okay, fine. So anybody want to add on to this? Are we going in the right progress? Are we, because I'm not trying to be judgmental on this, because based on my research, what I was trying to do, right, when I just wanted to go with this type of a thing, okay, when I go with this IBM and all those things, like, okay, what I was trying to get enlightened is, okay, nowadays all these things, right, are started to amalgamate, in the sense that there's no big difference between what we're trying to do with this data warehouse, because this data warehouse can go with both data schema, right, on read and write. Am I right? Any
So I think
yes,
the
Anupam.
data warehouse is a bit different from what the normal big data concept. Big data we can accept unstructured and semi-structured to as well as the structured data for big data. But for data warehouse, they only accept up to this structured data only.
Yes. I agree, my dear. This totally I agree. Okay. Totally agree. That is what I'm trying to tell you about. Okay, Geek of Geeks. Okay. We need to go with some discussion. Like, maybe you can go with IBM. Okay, Geek of Geeks is fine. Maybe we need to check with IBM Watson. Okay, the version of how they define data warehouse. That's the reason why I said case by case, and who is providing our data warehouse. Because I can just go with the book saying that, okay, fine, the data book says only that it can only take, we are going with traditional one, it can only accept tables, right? It can only go with the schema on write. Of course, right? But currently the market says that data warehouse is in the cloud. Data warehouse can accept schema on. That's the reason why you can very well see here. If that is the case, when you're talking about structured one, right, you cannot have this, right? How can they say schema on write or schema on read? Anko, are you clear in this?
Yes, sir. Clear.
Right. So that's the reason why I'm not saying that, okay, this is what is my statement is the only one, right? Because it once again depends on who is providing the data warehouse architecture as such. Are we clear in this? If that is the case, then we should be very clearly defining it, saying that it is only on write. It should not be on read, right? I'm sure all of you are reading this, right? Are we having clarity on this? Okay, thank you, Angpao. How about others? So I'm not sure. I didn't go inside what is Jig for geeks. Okay, but maybe you can go with IBM Watson. Okay, what the research white paper from IBM Watson, and also maybe you can go with AWS. Okay, how they define data warehouse as such. Okay, how they go with the scalability issue, the bucketings, and all those things. How what relatively they use, right? The terms they try to bring out the clarity on it. Yeah. So which means, so I think we agree to this, right? Lucian. So data is not traditionally only about schema on write. Am I right? Which means then it will accept only structured data then. Lucian, are you able to understand what I'm trying to convey here? The reason why we are discussing this, when we are very clear in this, okay, then what we progress in our slides will be very much easier for us to understand. So I guess data warehouse they provide on their cloud accept both structure and yes. Right? So we are having clarity on this, right? No doubts. Thank you. Fine. Anybody having doubt? Anybody already got confused? Anybody does not understand what is happening here? Please. We have so much experts here. We have Lucian, we have Angpao. They can explain us very well. Okay, everybody is clear. Fine. Can we proceed? Caleb, Chan, Wang, Donny, Praveen, Shanti, Agamat. Only these names I see in my friend screen. Okay, don't mistake me if you didn't call your names. Okay, thank you. Right, so we are clear in this, right? Okay. So what is data warehouse? Okay. What is multi-dimensional data model? Data warehouse architecture. Okay. So after discussing all these things, don't get me wrong why I'm going with the slides. Okay, because some slides we need to go with understanding of the architecture, right? Okay. And to be more specific with our academics, okay, we need to be having those things taken, right? So please take note of these things. These things will be helpful for your MQ multiple choice questions, right? MCQs. So what is a data warehouse, right? Decision support database that is maintained separately from organizational's operational database, right? And it can support information processing by providing a solid platform of consolidated historical data for analysis. So no doubt in this, right? I'm sure all of you surely agree to this, right? Consolidated historical data for analysis. So a data warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management's decision-making process. So this is how data warehouse is defined. Right? Subject-oriented, integrated, time-variant, non-volatile. Are we clear in these terminologies? Okay. So those who are clear, okay, please you can give your idea. What is the meaning of subject oriented. Very simple, right? Subject oriented means it is oriented based on the subject. So what subject? Maybe based on a company or corporate. Can every department act as a subject? Can. Yes or no? Can departments be put under subjects? So we can say when you talk about subject oriented, we can talk about more orientation towards what is happening to that particular process in a particular place. Correct? Are you able to understand?
So
So in
I
talking-
can how to relate this object oriented together with subject oriented? Object oriented I heard a lot, but the subject oriented is the first time I heard.
Okay, so maybe we can have one particular department finance, one department production, right? One department sales. So each department, okay, caters to the needs of that particular process happening inside that particular. What you call as the domain. Is it clear? So when we're talking about subject oriented, we're talking more towards reasoning, right? Or understanding towards a particular domain.
So does it mean the data warehouse we created, we will divide it into different departments? For example, sales department will have their own database inside the data warehouse, and then finance will have their own database, something like that. Is it considered subject oriented?
Yes.
Thank you, sir.
Okay, so I think that is how it is also being done in your place, right, Angpao?
The data warehouse part, I'm not really clear, but I know how they group the data into cube. Means finance will have their own cube, data cube, and then
Data cubes.
different department will have their own one. So we
And
cannot
they
access
can
to
call
other.
that as data marts.
Yeah. Thank you, sir.
Okay, fine. So it is just the terminology they use in every system. How about others? How about anybody who are using this in their system, their office? How do you use it? Okay, fine. Hope everybody's clear on that. So when you say integrated, right, we can have some processes, right, which we can also use. So when you're talking about querying, right, we can query only when we have sort of integration among these subject-oriented things, right? So that's the reason why we put them as integrated, because we can integrate between data marts can happen, right? Time variant, which means time bound, fine, and non-volatile because data is stored, right? It's not just removed as any particular non-volatile things, right? Because we're talking about permanent storage. Okay, and how well are we trying to safeguard, right? So security aspects should also be a part of the data warehouse stream. So are we clear in the definition? Any doubt on definition? Okay, this slide should be there. Is it not there? Okay, no problem. Okay, maybe in the break, I'll upload it. No issues. Okay, thank you. Hope we are clear on this, right? Okay. So the data warehouse is process of constructing and using data warehouse. So in talking about subject oriented, we are talking about organizing major subjects such as customer, product, sale, right? And focusing on the modeling and analyzing of data for decision makers, right? For analysis, and not for daily operations or transactional processing, okay? Mainly for analysis purpose. And providing a simple and concise view around particular subject issues by excluding data that are not useful in the decision support process, right? So to take note of a simple and concise view around a particular subject by excluding data that are not useful in decision support process. So here we are trying to get sense of how we are trying to get data from a typical data warehouse. Right? The way we are storing the data, okay, in the data warehouse. So integrated is all about constructing heterogeneous data source, which means it is having relational database flat files, online transactional records, right? So now I think you should be able to answer some questions that we have been discussing before, right? Talking about heterogeneous data source. It's not just about relational database. We're talking about flat files and online transactional records. Okay, so data cleaning and data integration techniques are applied. So this is mainly to ensure a proper process enabling, right? So this ensures consistency in naming conventions, encoding structures, attribute measures, right? So for example, when we talk about hotel price, we need to have a good understanding of the currency, tax, breakfast covered, etc. Right. So here in the currency, you should really be able to understand whether we're talking about in terms of euros or dollars or ringgits, right? So what type of naming conventions we are trying to adapt. So when data is moved to data warehouse, it is converted, right? So when data is moved to warehouse, it is converted in the sense we're talking about schema on write. Are we clear on that?
So just now, can you go back to the slide again? I have a
Yes.
question on this because I saw the meaning for the data warehouse is it actually involve relational database, flat file, online transaction record. All these are structured data, and then I'm thinking about, is it possible to incorporate this NoSQL or this big data together with data warehouse?
Yes, that is where some confusion arises because we're talking about the tools like NoSQL or MongoDB, right? So it depends on what type of data we are processing on. Not
So
all data.
meaning to say, if we want to integrate the data into the data warehouse, first we need to make the unstructured data become structured first, then only can be part of the data warehouse, or how is the
Okay.
concept? Not really clear.
We can have unstructured data as such, but just with our tools, right? We can also query unstructured data. Right. So when you have a text document, when you have just a comma separated values, right? It can just be a text document as such. No need to have a very predefined one, but just with that, okay, we can also use our tools to query them, or it can also be converted to a structure and then start querying. So it just depends on the way we wanted to go with the particular structured data. Right? Querying unstructured data can also be done, or converting unstructured data to structured data and then querying on the structured data can also be done based on what type of a tool that we are trying to use on our data warehouse. Is it clear, Anupam?
I'm still looking online for the definition. Not really clear on this one. Thank you, sir.
Okay, so which one you are not clear in this?
Because the data warehouse, something like it's a big things that we actually put all the database inside this thing. And then as I understand from this slide, it's more on structured data. So I'm trying to link this data warehouse with what so-called Hadoop, which is the big data. This is something I have a confusion there. How am I going to make non-SQL is part of my data warehouse? I'm trying to look for the graph or diagram inside Google, but it seems like no.
No issues. Okay. Maybe we can have some simple example. Okay, when we are doing. Wang Pei Wen. Okay, fine. Okay, so maybe we can have a simple examples using Hive. Okay, where we can just have a text data. So using text data, whether we can go with our querying. Okay, we can do that because when we are just importing unstructured data into our Hadoop, okay, we can use tools like Hive, which can actually do SQL statements on those data, right, without converting. It's not necessary that it has to be converted to a table and then we need to use querying on that particular table. Right? We can just use simple text data, right? And then it's text data when you start putting it in the Hadoop, right? When you can just play with your Hive to extract data from that. Am I clear, Ang?
Yes, sir. Thank you, sir.
Okay, how about others? Anybody having any other insight on it? Is everybody clear on what we're trying to discuss now? Any other feedbacks? What you have been using, how you're using from your side, from your office?
So I check online, mostly they actually differentiate Hadoop and data warehouse are two different things. And some say Hadoop replace data warehouse. So I think it's a two different thing, right? Data warehouse and Hadoop.
Okay.
Post
Okay.
the link here.
So how do they define?
I got a link inside the chat there, so you can have a look on that.
I think I did ask this question, right? Will Hadoop replace data warehouse or is Hadoop dying?
I think Hadoop won't die, right? I think we are still need Hadoop for process unstructured data, right?
This once again is repeating what I'm trying to tell you from the beginning. Right? Are you clear on that? Because Hadoop can store and analyze both structured and unstructured data. Right? The traditional EDW systems can process only structured data and store in the tables, which are in rows and column format. Right? This is the formula what is given by this data flag, right?
Yes, sir.
Okay, very good. So we now understand that the traditional data warehouse system only process structured data stored in the tables, which means that it is only accepting schema on write. Am I right?
Yes, sir. According to the statement, yes.
So which means that according to Lucian from AWS, it says both schema on write or schema on read.
Is it possible that the big data thing or Hadoop, they need to transform the data, become a structured data, then only can be part of the data warehouse? Is it something that the AWS try to explain there? This is what I'm trying to guess.
Okay, so as an academic point of view, okay, because I am not too much exposed in that data warehouse terminology that you're trying to confine with. Okay, So what we have been advised, okay, from the research, okay, from IBM Watson, okay, that data warehouse, okay, now as it is being explored and being highly used through cloud, right, can be used both for schema on read and schema on write. Is it clear, Angpal?
Yes, sir.
So is my statement clear?
Yes.
So which means it can accept structured data. So you can query on the structured data. It can also accept unstructured data. You can query on the unstructured data or change the unstructured data to structured data and query on the structured data. Am I clear now? It once again depends on what tool you're going to use. So you're only using Scoop when you just wanted to track data to a Hadoop system, right? You can use Hive when you wanted to go with getting data or finding data from an unstructured data source, right? Or you can also have pick scripts written, right, to play with structured data.
So I think I find the diagram already. I'm not sure this diagram is it correct or not. Maybe you can have a look on this diagram and give your comment on this one. Thank you, sir.
Yes, this is what we are trying to discuss now. Like, because flat files, log files, CSV. Okay. So do we call flat files, log files as structured, semi-structured, or unstructured? Yes. Are we able to understand this?
Flat file should be structured, and log file, I'm not sure is it considered semi-structured or not. Log file.
So that is the reason why we put them under the category of semi-structured, right? Okay. Is it clear, Anpal?
Yes, sir. Clear.
Okay, fine.
Thank you, sir.
So now we go with relational data sources, which is we are very well aware that it is going to be structured, right? Because tables, right? And then we have our NoSQL application database and also our web applications. And all these things are going to be some application that can run on HDFS, right? Which can input data or it can also interact with HDFS. And we have Hive, right? Which we can work on HDFS, which means that we can query what is there in HDFS, because what we do, we actually try to get data, right? And we're trying to put it inside our system through HDFS. HDFS is nothing but Hadoop distributed file system. Right? Are we clear in that? So we are trying to take data, right? You can just use wget for if you in case you wanted to just track from a web source, you can just use wget for getting it from the web. Just dump it in your system, right? Through HDFS. And then you can start querying on them through Hive. Right. So here we can talking about data warehouse in the sense because we are having all those data, all these log files, relational data, right, web data, all those things, because we are putting them inside this data store, we are actually calling them as a data warehouse. Right. And then based on the data that is inside data warehouse, we can start doing analytical discussions. So data marts are once again inside our data warehouse, and we can use BI like how you use for your data lakes. You can use reporting tools for your visualization. Right. So I think this is once again what we are trying to discuss. Right. And Paul, is it okay? Clear? Fine.
Yeah, now clear, very clear. Thank you, sir.
Any doubts? Anybody is not clear with? Still having some doubts? So log file, it once again depends on what type of log file, right? Whether it is semi-structured or unstructured. Okay, are we clear on that? Okay, fine. How about Wong Liu? Okay, so maybe we can have a small break before we start. I think it's already more time. Most of you are already tired. Hope we are having very good understanding on this, right? Because these things are really important. Right. Once this is clear, then yes, Wong. Yes, you can do some reading. Okay, it's reading. It's not just about reading the slides. It's about doing some research. Right. You can do more research on this. Okay, based on because there are so much of blogs nowadays. You may get confused or maybe like dragon away. Go with white papers from corporates. Okay, maybe you can go with Google white papers, or maybe with IBM Watson, right, or AWS. Okay. All research papers will be helpful to give more clarity on this. Okay, Wong's view. Okay, thank you. Okay, so this time is 8:15. Okay, we'll have a break for 20 minutes, right? And then we can start. Okay, thank you. Okay, we'll come back. Okay, what is the update? Any doubts, any progress, any clarification? So I just wanted to put these two diagrams to give some clarity. Okay, hope it provides some clarity. Okay, so after we discuss on this data warehouse slides, okay, we'll have more insight towards this concept. Okay, any doubts so far? Okay. Sounds clear. Before we go into slides, we'll have a attendance so that we don't miss the attendance. Kindly mark. Junita Merlin. Nurul. Nurul Shahira Binti. Address.
Yes, I'm here.
Yeah. Trisha Patel. Theban, NGB, Noor Sabrina,
Yes, sir.
is it NGB? Is it NGB or Noor Sabrina?
Sorry, Sabrina, sir.
Okay, thank you. Raymond Yageshwaran.
Driving.
Okay, noted. Chupak, okay, done. Okay, thank you. So I think we are clear with the key terms, right? So we are discussing about subject oriented, integrated, time variant. So it's across what we call as the time, right? The reason why we put this under the concept of time is significantly longer than that of operational systems. Why? Because we're talking about getting historical perspective, right? Taking data of 5 to 10 years, by which we can start doing some prediction or analysis. So that is the reason why we wanted about to have a very long period of data, right, stored in this particular data store, which we called as a data warehouse. Right, so operational database, which is nothing but current value. So here we're talking about more information from past years. So key structure is all about element of time, explicitly or implicitly. So the time element is also a very important factor here. The non-volatile nature is mainly because of separate store, physically separate store of data transformed from operational environment. Operational update of data does not occur in the data warehouse environment, right? So does not require transactional processing, recovery, and concurrency control mechanisms. It requires only two operations data accessing, like initial loading of data and access of data, right? So are we clear in this? Why we say operational update of data does not occur in data warehouse environment? Any insight on this? Why do we say operational update does not occur here? Is the question clear? Yes, class, am I audible? Is my question clear? Okay, Anpal says no idea. How about others? Okay. Okay, the question is clear, right? So can somebody repeat the question? So this brings to our understanding of OLTP and OLAP, right? The question brings to our understanding about OLTP and OLAP. My question was, it is stated that operational update of data does not occur in data warehouse environment, right? Why? Because the data warehouse is not intended, right, to be like our typical database, right? So in typical database or relational database is what we are trying to discuss on this type of OLTP, right? What is OLTP? Online transaction processing. So online transaction processing only happens in these types of relational database, right? Whereas in data warehouse, the main concept of data warehouse is mainly for OLAP, online analytical processing, discussing historical data, getting patterns from historical data. So in historical data, we're not trying to do any updates. Right? Only in real time, right? Like withdrawing money from the bank or your transaction using your ATM. All these things are OLTP, online transaction processing, which is literally being done in our relational database systems, right? So are you clear on this? Why updates are not being done in a typical data warehouse system? Ang Pao, Noor.
So does it mean that the OLTP will happen first before OLAP? So OLAP will be performed in the data warehouse environment. Is it correct, sir?
So now we are discussing about traditional data warehouse. Okay. So in traditional data warehouse, we are only discussing about historical data. Okay. In historical data, we will not go with OLTP. We will go only with OLAP because there is no transaction going to happen in historical data. Historical data means data that is already been stored, right? Even data that is yesterday's data is history, right?
I think I understand what you're explaining. It's something like a batch job run. The IT will run every day, once a time or twice, a few times a day, something like that to archive the data for OLTP to the data warehouse. Is it correct, sir?
No. OLTP, even if you're going to do some transaction with your bank, right? You're using your ATM in an ATM machine, it's under OLTP. It's not just about batch processing, right? So all processing that is happening, right, in real time on batch processing can also be under OLTP. Whereas in OLAP, we are talking only about those analytical processing that is happening, right? So why do you analyze some data, right? We analyze data so that we are trying to get some sort of an knowledge from the history that has happened. Maybe you want to forecast something happening in the quarter, right? So you take historical data, right, to do something with that. Okay, it's relative to what we are trying to do in our typical real-time systems, in your real-time database systems. Is it clear?
So does it mean the data warehouse only kept the historical data? Let's say if want the current data, will it available or will it need to run a certain job in order to get the current data to appear in the data warehouse?
Right. If our data warehouse is not in the cloud, right, we'll go only with what we call as discussed before. No. Okay, no issues. Right. So the reason why we are talking about the historical perspective, right? In case you wanted to discuss only with those data, okay, that needs only OLAP processings, right? We are not going to do any update on those data, right? So operational update of data does not occur in this type of data warehouse environment. Okay, so this is once again, that is what I'm trying to make it clearer. Okay, not for a typical data warehouse in which we are talking about in terms of cloud. Okay, in case we are talking only about OLAP systems, there's no update going to happen on those data. Right, that's the reason why we put that as we're initially loading the data and then we only access data, right? Accessing the data sense maybe for querying or maybe for finding some patterns, right? Not for updating. Yes.
because I'm observing what is the practice in my company. So my company is using SAP. So all the real-time transaction will be posted into SAP system. And then we have another tool called reporting tool, and that reporting tool actually get the data from the data warehouse. So and I quite often see the IT actually mention is the data being refreshed or not refreshed. I think they need to run certain batch job, to get the SAP data to be populated into the data warehouse so that we can extract it using our reporting tool. So is it this reporting tool process all considered as OLAP? When the IT need to run the whole thing to archive the historical data into the data warehouse is what I try to connect.
Yes.
Thank you, sir.
Okay, and this batch processing will be done only during
non-office hours. Yes.
Non-office
Weekend.
hours.
Yeah, thank you, sir.
Right, because only during those time transaction doesn't happen. Okay, and that is the reason why we put them as batch processing. And also in you can see in banks, right? In banks, not all banks will operate 24/7, right? We see that like in midnight, like maybe like for each and every bank, right? They do have the timing, like maybe like from 1 a.m. to 3 p.m. or maybe from 12 p.m. Sorry, 12 a.m. to 2 a.m. Right? So they may just have those hours where you will not have access to your ATMs because transaction will not be possible because batch processing will be happening, right? And during those times, okay, only they're doing all those updates, right? And during those time, it is also like after they finish the updates, they can do some processing if in case they wanted to do any processing, right? Like doing analysis can be. It's once again based on what batch or what scripting they are trying to do on it. Right? Anybody who are more familiar on those things because most of them are finance. Anko, I think we are clear on that, right? That's what
yeah,
your office.
now clear. Thank you, sir.
Thank you. How about others? Anybody? How they do in your office? Is it the same thing they do or a little different? How about Noor, Sabrina, Praveen, Wang Meng, Caleb, Yulok? Or is this topic very new to you people? Praveen saying outdated, like, is it going to be like using IBM mainframes?
In the slide, it mentioned non-volatile for the data warehouse. What does that mean? Do you have both volatile and non-volatile for data warehouse?
We don't have volatile. You're right. That's a really good thing. Okay. That's the reason why I said in academic, we practice some things to make sure that we follow definitions, right? So this is just to make sure that we are clear on that. Thank you, Chu. Right. We don't have any volatile, right? We don't want to have data to be stored and deleted. Volatile current data, non-volatile historical data. No, in terms of systems, right? We talk about volatile, non-volatile in the sense of permanent and non-permanent. Yangpo? Okay, thank you. Okay, so we have some history and some theory to be learned. So how are organizations using information from data warehouse, right? So many organizations use this information to support business decisions because we're talking about historical data, right? So it's useful for making decisions. So it increases customer focus, right? Which includes analysis of customers' buying patterns, right? Of course, and this can be used based on the buying preference, right? Which can be analyzed based on buying preferences, buying time, budget cycles, and appetites for spending. So these are some ways in which the buying patterns can be understood. So repositioning products and managing product portfolios by comparing the performance of sales by quarter, by year, and by geographic region, which is nothing but demographic, right? In order to fine-tune production strategies. Right? So I'm sure all of you are aware of these things, right? Repositioning products and managing product portfolios. Right? The way in which products are arranged in any supermarket, right? Which product to go on the low shelf and which product to go in the higher shelf, right? OLTP versus OLAP, right? So talking about users, OLTP usually by clerks, IT professionals, because we're talking about our usual query that we do with our system, right? Checking the values, right? Or maybe checking the relevant transaction details, right? So that is why it goes with clerks and IT professionals. OLAP, knowledge workers, right? So we put knowledge workers as data scientists, right? Or data gurus, right? So who are trying to gain some knowledge, right, out of those patterns that they discover. So OLTP is a day-to-day operation, right? And OLAP is not a day-to-day, it's based on decision support that they try to do. And in DB design, in OLTP, we are talking about ER diagrams, right? Enterprise, right? Or entity relationship diagrams, mostly related with this type of enterprise architectural things, right? And star, snowflakes, and subject-oriented things are mostly for OLAP. So in data, we're talking about current, up-to-date, and the flat relational isolated data. In OLAP, we're talking about historical, summarized, right? The augmented one, multidimensional, integrated, and consolidated data. So in usage, OLTP, it is mostly repetitive and ad hoc. Unit of work is short, simple transaction, and in OLAP, it is a complex query. Right? So OLAP also do have queries. Right? The thing is that we're trying to talk about complex queries, which mostly talks about you can use joins, right, or indexing, bucketing, right? So all these things can be going well with OLAP, right? So record access, right? We're talking about tens or hundreds of records that we are trying transaction every second or something like that. Okay. In OLAP, we're talking about transaction of records. Okay, millions of records per second. So users, thousands of users will be using OLTP, hundreds of users will be OLAP, because not everyone are interested in this type of decision making, right? So DB size, comparatively, OLTP is smaller than OLAP, right? So are we clear in this? OLTP with OLAP. Okay, very good. Business strategy, business process. Okay. So can anybody explain this? Ongpo, can you explain this?
Yeah, try to imagine from bank's perspective when we do the debit and credit inside the ATM machine, so which consider business process, and then this transaction will not be go into the data or this OLAP for data warehouses. They will store in somewhere a more volatile kind of database. And after that, during like what you mentioned, so during at night, IT will run the batch job and then push all the transaction data, the live transaction data into the data warehouse for the analyst or data scientists to do analytics. This is what I'm trying to I'm trying to visualize. Maybe this is, I'm not sure it's correct or not.
No. It's all about how we tell the story.
Thank you, sir.
Okay, thank you. Anybody who don't agree the story? Thank you, Anupam. Okay, so here once again, all right, because we discussed that this data residing in terms of a banking, a financial institute, right, where data is being stored and then retrieved, right, that is fine, okay, but it's not the case always, right, with all types of data warehouse. Right? That is the reason why I said case to case basis, right? And not all data warehouses are also used in these types of cases, right? Where they store data, right? And then maybe they once again process the data, right? Because most database, their data warehouses, right, were not designed for this purpose. They were designed mainly for storing, right, and for doing analytical purpose. Right? So we just wanted to have a clarity on that.
Also,
Okay,
can
so-
I ask you one question? Is there any environment or creation of the tools that we want to process or analyze the data, the live data, rather than go through OLAP? Can we analyze the OLTP data immediately if there's any transaction happen? Something like Spark, I'm not sure is it consider.
Okay, come again.
I mean, currently that what we are studying, we need to go through OLTP, and then after that we only can analyze the big data. I mean, a huge of data using OLAP, right? Because this OLAP need to be there so that data scientists they can access to the big data to analyze it. But OLTP they are not suitable for data analytics because the transaction live data, maybe it's a live data, maybe it's because the data model is not ready for data analytics things. That's why we need to go for data warehouse to analyze the data. So my question is there any tools that can help us to analyze the live data rather than need to wait for a few minutes or few hours in order to get the data?
Yes,
Yeah.
you already gave the answer, right? We can use PySpark.
Okay, thank you, sir. Got it.
Okay, also Scala can also be integrated along with it, right? So because we do have tools nowadays, that once again depends on how we are going with, okay, and what type of a data we are trying to bring forward. Okay, because this financial transaction data, fine, yes, okay, but it's not all the cases that we can do this type of thing, because financial things, yes, can, okay. But what about data that is so massive, right? When talking about huge population as such, right? From where you're trying to get details about demographic things. In those cases, cannot. That's the reason why we go purely for data warehousing, right? Where OLTP is not going to be done, right? It's only for OLAP, dedicated only for OLAP. Okay, and that is case by case. Okay, and for financial things mostly, okay, we have tools that is more capable of doing these types of OLTP and OLAP. Okay.
Yeah,
Anupam?
sorry, sir. I've maybe can try to look at data virtualization as well, right? Building DSS for database. So that's another way to analyze live data. May not be as live as possible. I think there's some certain delay, but I think data virtualization or DSS is another way to answer a couple of questions.
Based on some few time delays that they pose, right? It happens because that is how we are getting relays. Okay, like stock displays and all those things. It's happening. It's happening in the real time. Yes. Right. That's really good input, right? Thank you, Chupa. Any other valid discussions, valid suggestions, like how you are doing it in your office? I think we are clear about what you're trying to discuss now, right? Any doubts? Yes, data visualization, yes. Any other doubts, any clarities, Any feedbacks? So hope everybody will write. Will give good answering, right, when you're asked on these tips like OLTP, OLAP in interviews or test. No doubts, right? Okay, fine. Thank you. Okay, so why separate the data warehouse, right? That is what we are discussing, right? So we're talking about high performance for both systems, right? DBMS is tuned for OLTP, right? Based on the access method, indexing, concurrency control, recovery. Warehouses are tuned for OLAP because of the complex things that can be played on it, right? Using OLAP queries, multi-dimensional views and consolidations, right? Consolidation, we're talking about the aggregations, right? And different functions and different data. So missing data and decision support requires historical data, which operational DB do not typically maintain, right? So these things like missing data, right, cannot be a part of your OLTP, right? That cannot be taken. And data consolidation, so in DS requires consolidation, like aggregation, summarization of data, right, to form heterogeneous sources, right? From heterogeneous sources, we can gather this data, which is more useful for our OLAP processings. And data quality, different sources typically use inconsistent data representations, so codes and formats, which have to be reconciled, right? So the codes and formats, I'm sure we did discuss, right? So maybe in Europe, right, they may have one particular type of a code, and maybe in US we have different codes, right? Maybe whether we measure in kgs or pounds, right, or kilometers or miles. So all these different types of codes and formats, right? When you're trying to get it from different sources, right? How are we having a consistency to put it into our data warehouse? So all these things should be taken into consideration, right? Okay, so I'm hope all of you are very clear in this thing, no issues, right? Because nothing. So we're talking about the 2D view of sales data for all electronics. Typically, we all know about the views in a table, right? A table, we have rows and columns, right? So here we are just trying to, this is just right, rows and columns. So for a particular location, Vancouver, okay, we are having the time quarter. This we are discussing as some sort of a 2D view. For time, which is a quarter, okay, and for the location, Vancouver, the view of data, right? How we are trying to view data in terms of time and location. So this we are just trying to visualize as a 2D view, right, of sales data for a typical company called All Electronics, right? Are we clear in this? This 2D view? Any doubt in this 2D view? 2D view of data? No doubt. So from 2D, we are trying to move to 3D view of sales data for all electronics. Right. So this is a typical book example, right? So in all data mining books, right, when we go with 2D and 3D, this is the example that we discuss. Okay. So before we discuss about this particular location, Vancouver, okay. So now for Toronto, New York, and Chicago, for the time, right, based on the items. This is what is our table, and when we are trying to put it in a cube, right? We just wanted to put it in a cube and just see whether it sits into the cube, and we are able to visualize how this data can be treated in the cube, okay, for a 3D view. So you can see here the time series is in one particular dimension, right? Q1, Q2, Q3, and Q4. And we're talking about the items, right, in one particular sign, and location, right, in the another dimension. Are we getting this? Are we getting this point? So this is a 3D view of sales data, right?
So it means the data set they're going to create is consists of many tables, right? In order to create different views, or one table will. I'm not sure when table is able to create this data.
Yeah, we have multiple tables, but this is just a visualization of these particular values.
Got it, sir. I think I understand. Thanks, sir.
Okay, fine. So similarly, when we have a 4D view of sales data, right? So what we are trying to do here, because before we are discussing about time, item, and location, right? So now, when trying to get another entity, so here the entity is suppliers, supplier 1, supplier 2, and supplier 3, right? So now we are having a 4D view of sales data. Right? So our human perspective is 3D, right? So higher dimension like 4D, 5D do exist, but how we are trying to visualize is the point of the observer. Okay, so are you able to understand this? So this is 3D. Along with this, we put as a 4D. Are we getting this? Anybody having doubt, or anybody can have more clarity on this? Can explain more dimensional point? How many of you have moved to further dimensions like 4D, 5D, have more clarity on the 8Ds? How many of you have seen those explanations on different dimensions? Are we clear on this? Anybody having doubt on this? 4D view of sales data. Okay, can I move on? Okay, do not worry, we're not going to have any questions on this. This is just for us to understand, okay, before going to more lattices, okay, discussing on lattices and how these things are trying to be played with data as such, okay. So from tables and spreadsheet to data cubes, a data warehouse is based on multi-dimensional data model. So to make this point clear, we are talking about 3D view and 4D views. Right? Are we clear? Can I get some responses here? Because I'm seeing most of them very silent, maybe because of the time. Is it very late? Okay. Okay, can you stop with this? 4D views, so we discuss next class. Okay, can follow, friend can follow. Friend can follow. Okay. Okay, fine, no issues. Okay, so we can continue next class from 4D. I'll upload this data, right? These slides, okay, into our model, and also I'll upload the Hadoop
Also, one question about this data cube, because data cube I'm using as well. So I'm not sure how they construct this data cube. Are they using SQL to join different table to come up with this data cube?
Okay. So how about in your office? Are they using, because here, if in case you're using Apex in Oracle, yes, we can do, you can use SQL, right? Because that is also one particular way of using.
Because for
cubes.
my company, actually they built something like inside a BAX analyzer, and then the inside BAX analyzer they have many dimensions, so we can pick the parameters and then create our own data set out already. So I'm not sure how behind the architecture how they build the whole data cube. I suspect it's using SQL, but in reality I'm not sure how they create that whole thing.
No, they use SQL. That's the reason I'm saying about Apex, right? They use SQL, but the architecture is based upon the particular domain, like how you want to use it. Okay, because it increases the complexity, like because here we're talking about only 4Ds, right? Because it depends upon what type of data cube your company is using, so it can vary. So now we are just trying to visualize 3Ds and 4Ds. Okay, in our particular example, we didn't go beyond 4D.
Okay, got it, sir. Thank you, sir.
Okay. So we're just trying to make it more simple to make it understandable, right, in terms of how we use it. Okay. So here we're just going only with 3D and 4D, and then we're just saying that, okay, because we have this 4D idea, so multidimensional properties can be very well understood, or multidimensional data model can be, right, and valid point. Okay, why we go with the data warehousing concepts as such, right? Why we have data marts inside data warehouse, right? How we are trying to help the subject-oriented nature of data warehousing concepts, right? Okay, so I think hope we are having some clarity on this. Okay, so okay, so this is mostly towards our understanding about this theoretical concepts. Okay, we are not going deep into any programming part of this thing. Okay, and the reason why I was saying that, okay, we can have some workshops, okay, because we don't want to we call as put more things, okay, to make it too lengthy, right? Or because it actually doesn't go with too much of complex things. Okay, we wanted to make sure that we are very clear with what data management things we want to do with this particular architecture as such. Okay, fine. Okay, thank you then. Okay. Okay, good night, everyone. Thank you, Anupam. Okay, everybody's clear on this. Okay.
Thank you, sir.
Thank you, everyone. Okay. Thank you, Azrina, Shanti, Noor, Dan, Mike. Okay, so stop the recording.